this morning with a moment of silence or remembrance our God and Father. What's wrong with my phone here? Can you see this writing?
Yes, can.
Okay. Okay. Today we are going to look into the cross section that is not symmetry. Are you with me, guys?
Yes.
So far, we draw the cross section, the symmetry, whether it's solid or hollow. Symmetry, right? So the stress on the top and the bottom is the same. Today we're going to look into the cross section that is not symmetry. Are you with me, everybody?
Yes.
Yeah. Again, when we load things, can be a lot. This loading stuff can be like that. There is loading P. This also can be 3P, and then there's a 1P there. This also can loading. Are you with me, guys?
Yes.
This is also can be loading. Yes. Where is the maximum one? And relate with the cross section. So all can be done. So the loading is no problem. We have done the loading part. Yeah. Maybe the distributed one you haven't practiced again. You have done that distributed load before in solid 1, solid 2, and then how to relate with that cross section, no problem. Okay, go back with that one. This is the cross section now. Let's say a simple word here. The cross section is like that. So this is not symmetry. You see that?
Yes.
This is what I mean. The cross section is not symmetry. How do we bend the cross section that is not symmetry? The stress on the top and the bottom is different. So the first thing that we have to realize from this non-symmetry stuff is that, where is the neutral axis? First one is the position of the neutral axis we have to find out. If you see here, close to the top or close to the bottom?
Close to the top.
It's not in the middle anymore. Yeah? Let's say this is 20. This is 100. So this is 100, this is 20. 100 times 20 and 100 times 20. So the height is 120. It's not at 60 anymore. Must be close to the top because all the area is on the top there. Are you with me?
Yes.
So the first step, we have to find the position of neutral axis. Still remember this in static?
Yes. Still
Yeah?
remember.
From static. So first step, find X bar. What is X bar? The position of neutral axis. From where? From anywhere you decide. If you decide you want to measure from the bottom, your X bar is from the bottom. If you decide from the top, it's pi from the top. If you decide from somewhere else, here, it's from that distance. Are you with me, guys?
Yes.
X bar, what is that definition? Position of neutral axis. Okay. Let us do that. Remember what is the formula for that? Who still remember?
A1, for me, I remember Y1. A1, Y1 plus A2, Y2 over A1 plus A2.
Exactly. Yeah, X bar is equal to A1 X1 plus A2 X2 over plus A1 plus A2 and so on. That's X bar. Change that into Y bar. That is your Y. That is your Y. Are you with me?
Yes.
So all that X or Y that one, or Y bar that one, whatever it is, you must have a starting reference where you want to measure it. Yeah? Where you want to measure it. Let's say we want to measure it from here. Yeah? Want to measure it from here. That's your reference. So you must decide which area you want to set. So this is one area. This is area 1. Second one, bottom here is another area. That's A2. And then dot the point of the centroid of that area. Here is the centroid there. It's 20 there. So this distance here, we call it Y1 because area 1. This centroid here, 100 there, centroid there. The distance here is Y2. And then we decide, what is Y1? Half of 10, half of 20 is 10. What is Y2? That is 50. That is 20. So Y2 is 70. Can you see that?
Yes.
Everybody? So, and then we fill up here. What is area 1? 100 times 20. Area 1. 100 times 20. What is Y1? Y1 is 10. 10. What is A2? A2 here is 20 times 100. What is Y2? Y2 is 70. And then divide by the area. A1 plus A2. A1 plus A2, 100 times 20 plus 20 times 100. Yeah, how to simplify this? This is 2 times that one. So 100 times 20, 100 times 20, this one, what's left? 2. Are you with me?
Yes.
So 10 plus 70, 80, divide by 2, 40. So 40 mm from the top. That means that this is Y2. We're finding Y bar. Y bar is somewhere here. There's 20, another 20 there. So that is your centroid. That is your centroid. It's equal to 40 from the top. Are you with me, guys?
Yes.
This is just a revision. Okay. How do we confirm what we have done here, what we are talking about this morning? We talk about that reference can be from somewhere else, right?
Yes. From
No?
bottom.
Can I do my reference from here? Yes? What is Y1 bar? What is the value of Y1 there?
110.
110.
Yeah, 110. What is the value of Y2 there? If you do the bottom reference,
50.
50. So we put that. This is 110. This is 50. So what is the value there? 110 plus 50 is 160, right? Divide by 2, 80. So you put 80 from the bottom, the same position, not 40 from the top.
Yes, the same position.
It's not this value is important. This value is not important. The position of that neutral axis is important. Are you with me, guys?
Yes.
Neutral axis is there. Once you got it, I don't care this 80, 40 anymore. Because that neutral axis is there. Okay, clear?
Clear.
Okay. So now, what if I have a moment there? Where does moment rotate?
About the neutral axis.
Moment always rotate at the neutral axis. If there's symmetry there, rotate about that symmetry. If it's not symmetry, it rotate about the neutral axis, which is 80 from the bottom and 40 from the top. Are you with me?
Yes.
Now, go back to solid 1. Sigma is equal to my over I. The same moment here. Let's say the moment is 100 Newton meter, 100 Newton meter. The cross section, you can calculate the I. Which one has become yield stress first? Which one is the higher stress? The top or the bottom? This is what I call thinking question. You should ask yourself again and again to understand what is bending moment. The same moment there, tensile on the top, compression on the bottom. The top and bottom one, we increase the moment. Which one become yield first? We know that. Is that the same stress? Top and bottom? Hello, everybody?
Yes.
No. The stress depends on the Y. The Y here is 80. The Y here is 40. So the stress here is always less than here. Very simple understanding that. Can you see that?
Yes.
So, the stress diagram depends on the Y. The stress diagram is like that. If that is 200, 200, 200, here is only 100. This is 200. Because Y there is 40, Y here is 80. It's not in the middle. This basic thinking, you must have this basic thinking. You don't understand what is sigma is equal to my over I. You don't understand the concept of Y that one. You just remember in your head like Form 5 student. What is that? Graph stress like that. 200, 200. This is rubbish. Learn by memorizing. Are you with me?
Yes, doctor.
This is what I call rubbish. Rubbish engineer. You already learned about this one. Sigma is my over I. The I for that one got a value. Let's say the value 50. The moment here is 100. So the stress at any point there depend on the Y divided by 50. So depend on Y. Y here is 40, Y here is 80. Why cannot you see from a simple equation like that? The stress is not the same. This is what I call lack of thinking skill. Because you haven't asked yourself, what is the meaning of that? Why? How do I get that value of stress? That question demi question, with another question doesn't come out at you on your own. That means you are not studying at all. What is the equation for? This is what I call technician material, not engineer's material. Your head is technician material. Doesn't fit at all to become an engineer. You got an equation, you don't know how to dig that equation. Are you with me?
Yes.
So what to do? Ask. Ask yourself. This is what I call asking is digging. This is what I call asking is thinking. Start from asking yourself. Okay. We know that just now. Yeah? 120, 120 there. So the neutral axis is there. Neutral axis. This is 40. So this is 80. Okay? A bit. Okay? And then the stress diagram is what? Who's going to reach yield first? Quick, top or
The
bottom?
bottom part.
Yeah, the bottom part will reach yield first. Let's say this is 200. The yield is 200. So the bottom part 200. The top one is just 100 because half of that distance. Because 40 and 80. So that is 200 then. So this is the diagram of what? This is the diagram of when you want to calculate moment. Moment what?
Moment maximum elastic.
Yes, or start of plastic. Because 1 point here, not 2 point. 1 point here is 200. So there's 1 layer here. Yield, only 1 layer yield. So that's the meaning of moment start of plastic or moment maximum elastic. This is the one. Now draw this side by side. Are you with me?
Yes.
So how to get that moment? Same again, because we have know the neutral axis there. So this 20. So how to get the force? Break into area, remember that? That area, break into triangle and trapezium. Trapezium because triangle and... Are you with me there?
Yes.
So, very quick there. That is 200, that is 100. So what's the length of that one? Quick. This is 40, this is 20, this is 100, this is what?
50.
Very quick. Okay, half of that. This is 50, this is 100. So we have a triangle of 50 and 0. We have a square of 50 and 50. We have a triangle here, 50 and 0. Do you see that?
Yes, can see.
And then we have an area here, 120. And then we have an area here, 20 and 20. Can you see that?
Yes.
So we have F1 there. We have F2 there. We have F3 there. We have a D1, D2, D3, and then we have F4 there. D4. That is area for F4. So the square here, this area. The triangle here, also this area. The bottom triangle here, the bottom area here. Very clear now?
Clear.
Clear. You can calculate your moment maximum elastic.
Elastic.
Or start of plastic. Let's say the moment is now is, let's say 12 kilometer. Let's say, for example, what if I increase the moment higher than 12? What happened to this shape?
Got rectangular, got plastic area, region.
So how do we anticipate the shape of the stress diagram? So this 12, this yield stress area will stay there, become bigger area. The plastic become bigger, right?
Yes, bigger.
So if the plastic diagram become bigger, what happened to the stress diagram? This also become 200, right? And then there's another like that. Are you with me?
Yes.
So this is not 100 anymore. Become higher and higher, right?
Yes.
And then become bigger there. So sometimes this is 200 now. Can it be like that? Can you imagine be like that? More bigger moment, what happened? This one become higher, this one become that one. plastic. This is still elastic, but one layer of top become plastic. This is 200 now. Right?
Yes.
More bigger of that, what happened? This become up here, more bigger, so more bigger there. So this is become plastic more and more on the top, right?
Yes.
And so on. Bigger, more. Bigger, more. But the plastic become bigger on the top. The plastic on the bottom also become bigger, right?
Yes.
So this is what happening until all are fully plastic, right?
Yes.
But the process of that one, can you see that one? Start from the bottom, increase up, and then the plastic also start at the top and then coming down.
Yes, can
That
see.
process from the beginning until the end, you must imagine. Are you with me?
Yes.
Okay, now, what happened to the nucleic acids? Then the question comes. Right? The question comes, what happened to the nucleic acids? Yeah. From the beginning, we have elastic, maximum elastic, and then we have separaplastic. And then we have separaplastic, and then we have fully plastic. Take at the beginning just now. We have nucleic acids there. This is 40, this is 80. The diagram of the stress is like that. 200, this is 100. Okay? Now, let us calculate that thing just now. This is 50, this is 50, 50 and 50 and 0. The area 100 times 20, 20 times 20. This is 80 times 20. This is 200, this is 100. 100 not exist anymore. We have a 50 and 0, 50 and 50. So we want to find out what is F1, F2, F3. Okay, what is F1?
Sigma average times area.
This is F1 here, F1. And then F2 there. And then F3 there. And then F4 there. Yeah? What is F1 there? Sigma average times area. What do we have there? Quick.
50 plus 0 over 2.
What's the area?
100 times 20.
100 times 20. Mega, milli, cancel out. So what's the value of F1 then?
$50 kilonewton.
50 kilonewton. Yeah? So now what is F2? 50 plus 50 over 2, and then we have 100 times 20.
100 kilonewton.
Yeah? kilonewton. What is F3 then?
50 plus 0 over 2.
Area?
20 times 20.
20 times 20. So what is the value of that?
10 kilonewton.
F4? 200, 0 there. What's the area?
20 times 80.
So what's the value there?
160 kilonewton.
Okay, Even though you bend it like that, it's not moving to the left or to the right. Why? Yeah? Even though a simple symmetry stuff, we have a F1 there, we have F2 there. Why is that it's not moving to the left or to the right, just bending, static like that? Why is that?
The move to the right and move to the right means what?
Doesn't moving, stay.
In what axis?
Static.
Oh, okay.
The answer is static. Why is static?
The force is balanced.
Yeah, see that? The force 100 there, same with 100 there not.
Yes.
Now look here. F1, F2, F3 to the right. F4 to the left. Is it balanced? This is easy. This is symmetry. You can always assume. Now we go to the non-symmetry stuff. We have to double check. F1, F2, F3, what's the value? 50, 110. What's the value?
160.
And then F4, what's the value?
160.
Balance not?
Balance.
Static means summation force in the X equal to 0. So F1 plus F2 plus F3 to the right minus or equal to thing to the left. See that? That one equal to that one. Only that. Even though the moment is there, only that. This is not moving, still bending, but static there. This must be true. If not, this is moving. Are you with me, guys?
Yes.
Are you with me?
Yes.
Now, this is what diagram? Moment, maximum, elastic. The neutral axis is 40 from the top or 80 from the bottom, right?
Yes.
Yeah? Now, let us look separa. If we assume what happened to the neutral axis, if we assume the neutral axis stay there, can we draw the fully plastic? Fully plastic is much easier than the separa plastic, right?
Yes.
So, can we draw the fully plastic diagram?
Can.
Yes? Let us do. The trace is there. This is the one. This is the one. Yeah? So this is 200. 200, 200, 200, 200, then 200 there. 200, 200, 200, 200. Correct not?
Yes.
Correct not?
Correct.
Yeah, this neutral is in there. And then that 200 times the area, we break into area there, break into half. See that? That area times that stress become F1. That area times that stress become F2. And then that stress times that area become F3. Is it correct not?
Yes.
Correct not?
Yes.
Then let us find out what is F1.
200
Sigma
plus
average times area. What do we have there?
200 plus 200 over 2.
200 plus 200 over 2. What is the area?
100 times 20.
100 times 20. What is the value?
400 kilonewton.
400 kilonewton. Now what is F2?
200 plus 200 over 2. 20 times 20.
20 times 20. What is the value there?
80 kilonewton.
80 kilonewton. Now what is F3? Bottom here.
200 plus 200 over 2 times 80 times 20.
What is the value there?
320 kilonewton.
Now, F1, F2 to the right, F3 to the left. F1 plus F2, what's the value there?
480.
What is F3? F3 to the left, this to the right, F3 to the left. What is the value of F3?
320.
Does it balance not?
No.
This is the problem. This is why we call here. What happened to the VHS? Not balanced. So not balanced means not right. This solution is not right. Are you with me?
Yes.
We assume the neutral axis there still maintain after elastic. During the elastic, no problem. We check just now the value is 320, right?
Yes. The value is the same. 160.
360, right?
160.
160. Now, when fully plastic, this is not balanced. That means what?
Neutral axis moved.
Neutral axis is not stay in that position. When they are in separa plastic until fully plastic, the position of neutral axis doesn't stay at 40 anymore. This is what we have to realize. So how do we find the position of neutral axis? How do you find the position of neutral axis? Just now we used the old equation, static. What's that? Y bar is equal to A1 Y1 plus A2 Y2 divided by A, right?
Yes.
That are all valid for elastic cases only. When they are separa plastic and fully plastic, that is not valid anymore. Are you with me?
Yes.
So what do we use to find that position of neutral axis? We use this fundamental. What is that?
Balance, force balance. Static.
Yes, force to the right must equal to force to the left. Are you with me?
Yes.
Force to the right must equal to the force to the left. Summation force in X must equal to 0. That is static. So what do we do? This is not true anymore. What do we do? Which one? That is unknown now.
Sigma.
This one A is your unknown now. Are you with me?
Okay. Yes.
X bar or A is unknown now. For your neutral axis, you're unknown, right? You don't know, right?
Don't know.
Yes. Solve it in that manner. Solve it in that manner. See that? Your A is there. 20. So that is A, 20. What is that height here? What is the length here? Huh?
A minus 20.
A minus 20. This is A. From here to here is 120, right?
Yes.
So that is A. What is that one?
120 minus A.
We must use this unknown in terms of the unknown there. 120 minus A minus 20. So we got 200 there, 200 there, 200 there, 200 there, 200 there. So no problem. That is your F1, that is your F2, that is your F3. We want to solve what? We want to solve this to the right. F1 plus F2 must equal to the left, F3. So that is your equation you want to solve. Inside here, we have unknown. What is unknown? A. Can you see now?
Yes.
So let us do. What is F1? Slowly there. Sigma average times area. What do we have?
100 plus 200 over 2. 100
What's the
times.
area?
Doctor,
What's the area?
100 times 20.
100 times 20.
doctor, where's the
What's your D1? It's okay. Solve for F first. What is F2?
F2 is 200 plus 200 over 2.
200 plus 200 over 2. 200. Okay, what's the area?
20 times A minus 20.
20 times A minus 20. Can I wrap this one? Make life easier. Okay? 200 plus 200 divided by 2, 200, right? So
Yes.
make life easier. So what is F3 there?
200.
Yeah? What is the area?
20 times 120 minus A.
120 minus 8 times 20, right?
Yes.
And then put that one into equation there. 200, 100 times 20 plus 200 times 20, and then A minus 20 equal to 200, 120 minus 8 times 20. Divide by 200, divide by 200, divide by 200. Divide by 20, divide by 20, divide by 20. You see that?
Yes.
So what do we have there? 100 plus A minus 20 is equal to 120 minus A. You see that?
Yes.
So bring this to the left. 2A is equal to 120 plus 20 minus 100. So 2A is equal to what then?
40.
40. So A is equal to what?
20.
A is 20. Where is A now?
20. From the top.
Exactly on that line. See that? 20.
Yes.
For fully plastic, it is there. For elastic here. So separate plastic must be moving from here to the 20 there. Are you with me, guys?
Yes.
This is a fully plastic. So the real diagram for this one is what? This is just F1, F2, F3 just to solve your 2A. Or A, what is that? 40. Once you know your A is 40 or 20 in this case, draw it back. What? Draw it back. What is that? The neutral axis is there. No such neutral axis at the bottom there. So your diagram must be like that. F1 and then to the left here F2. This is 20 times 100. This is 100 times 20. You see that?
Yes.
You know your neutral axis is there now. You know your neutral axis is there. See that? Neutral axis is on that line. Only then you write down back here. Only then you can solve your moment. Do back again slowly. The step just now, it's not for you to rock the step. The step must be there to find the A or neutral axis. And then what is your F1 now? 200, 200. What's the area?
100 times 20.
100 times 20. What is your D1?
10. Half of 20.
No? This distance is 20. So half of that 20. Okay? So what is your D2? F2 first. What is F2?
200.
What is the area?
100 times 20.
So what is your D2?
Half of 100.
50. Half of 100 equal to
50.
50. This is equal to 10. Now, from basic static, what is F1 and F2? Is it the same not?
Yes.
What is the value of F1?
400 kilonewton.
What is the value of F2?
Same. 400 kilonewton.
See now? 4 to the left and to the right is the same not?
Yes.
So, no problem. Finish on that finding the neutral axis. And now we want to find the moment. What is the moment for that to happen? Moment fully plastic. F1 times D1 plus F2 times D2. So this is not symmetry anymore. There's no times 2 anymore. You have to do it clockwise. This one plus. So 400 times 10. And then plus another one 400 times 50. So what is the value then?
$24 kilonewton meter.
So moment fully plastic is 24 kilonewton meter. Just now, moment maximum elastic, what's the moment just now?
We didn't calculate. We just find the F1.
Oh, we haven't calculate. Okay, we haven't calculate, no problem. So, moment fully plastic 24. This is not lambda 1.5 because this is different shape, right?
Yes.
So we can always find the lambda. What is the moment fully plastic divided moment maximum elastic? You have to calculate maximum elastic. We know the position is there, right?
Yes.
By the original y bar equation. Separa plastic cannot use the equation anymore. We have to do the hypothetical position first. Let's say the position is there. What is the moment? This is the diagram for the easiest one, because this is the diagram for fully plastic. What is separa plastic? For separa plastic, we have to be intelligent enough to draw where is the hypothetical neutralization. I don't know. Let's say the value is there. This is my A. How is the diagram? We decide the diagram. Oh, let's say the bottom part is plastic already like that. So the top was not yet. So how is the diagram there? So this is 200, and then this is a hypothetical, not the real one. And then, so this one is 200 there. Not 200. Let's say this is, I don't know the value, this is 200, this is less than 200. And I don't know the value also. How much that one? Are you with me?
Yes.
So this is the one. I also don't know this one. Let's say this is A. So, but this one I must know, right? This is become plastic already. Let's say 40 mm become plastic. 40 in the top, from the bottom become plastic. So this is the shape. This is 40. So this is not 200 yet. So this is A. This is 40. How you write this distance? This is 120, right?
Yes.
120 minus A minus 40, right?
Yes.
So what is the value of this?
80 minus A.
That is A. This is 200. What is the length of sigma A here? Can I find that one?
Can.
And then can I find my sigma B here? A, that one. So this must be A minus 20, right? Because this is 20. This is 20.
The top part should be 20.
Sorry. This is 20. This is A minus 20, right?
Yes.
The length here is A, right?
Yes.
So what is the relationship sigma A, sigma B, and 200? How you write that one? Sigma A divided by
A.
A is equal to
200 over 80 minus A.
yes. So you can write your sigma A is equal to 80 minus A divided by A times 200. All are in terms of A. Can you see that?
Yes.
And then can I write my sigma B? Can I write my sigma B?
Yes.
What is that?
Sigma B over 20. A minus 20.
20 is equal to
A over A.
200
over 80 minus A.
80 minus A. So sigma B is equal to 80 minus A over A minus 20 times 200. Right? So you got sigma A, sigma B. So you break that into triangle. Remember that? Triangle and trapezium. So this is sigma B, this is sigma B now. What is the sigma now? The sigma C here, what is the value there?
Doctor, I think it's 200 times A minus 20, right? For sigma
What is
B.
that?
Over
Huh?
80 minus A.
Yes?
200 times A
Oh,
minus 20.
200 is correct.
Ah,
A minus 20 divided by
over
80 minus A.
Just
Yeah?
now the sigma A also the balik ni.
This also terbalik.
Ah,
A
80 minus
80
A.
minus A.
Ah,
Correct.
ah.
Okay, So, okay, no problem. And then what is your sigma C then? Sigma A minus sigma B, right?
Yes.
Sigma C is equal to sigma A minus sigma B. Where's sigma C not? Yes. Okay. Fine. And then area got F not? Got F not? Got F not? Got F not? F3. And then F4. So what is F1 then? F1 is sigma C, right? Are you with me?
Yes.
Sigma C plus 0. Your sigma C can be found in terms of sigma A and 200 and A, right?
Yes.
And then plus the area there, 100 times 20. Change that into sigma A and 200, A and 200, right? And then
Yes.
what is F2? F2 is sigma B. Sigma B plus sigma B over 2. And then times the area. Area is 100 times 20. Are you with me, Dad? What
Yes.
F2 is? And then this area now got A minus 20. A minus 20 there. Yeah? You don't know the A. What is F3 then? Sigma B and 0. Sigma B plus 0 over 2. Remember that? Your sigma B is in terms of 200 and A, right? And then your area now is 20 times A minus 20. You have 3 then. F4 then. What is F4 then? F4. What is F4 then?
200
200
plus
and 0. 200 plus 0. And what is the area there? That one.
20 times 80 minus A.
Still the unknown is A, right? Are you with me?
Yes.
What is F? F3. 1, 2, 3, 4, 5. F5. So what is 4, 5? 200 and 200.
200.
Yeah? Go by 2. And then the area there, 40 and 20. 20 and 40. So no A there. But got A there. Got A there. Got A there. Got A there. Are you with me?
Yes.
Solve the equation F1, F2, F equal to F3, F4. Solve that equation. What's that? F1 plus F2 plus F3 is equal to F4 plus F1. Where this one come from? Summation false and S equal to 0. Which one do you solve here?
Separa plus 2.
A.
Oh, A.
That equation is to solve your position of neutral axis. Long procedure not?
No.
Long. For separa plastic, it's quite long procedure. But still can be solved. Are you with me, guys?
Yes.
So furthermore, let's say the question say, what is the moment for the top surface to become plastic? You have to make a decision, that one. What is the moment for the top surface become plastic. Top surface become plastic. Thinking skill first to understand the wording. Top surface become plastic. Require higher thinking skill to understand. Top surface become plastic. You have to decide, oh, this is separa plastic. The top surface become plastic. So the top surface stress is 200. The bottom part, long time ago, 200. The bottom part, long time ago, 200. Are you with me?
Yes.
I don't know this height, but I know this is A. That is 200, that's 200. This must be A also. You see that?
Yes.
200 and 200. Triangle and triangle, A and A. So this must be 120 minus 2A. Can you see that?
Yes.
So the line of plastic here is 120 minus A. This is all this decision that you have to make when they say the top surface become plastic. Thinking skill to understand the wording first. Come to that diagram. Are you with me?
Yes.
I'm quite worried if you don't have a thinking skill. You just do the working as if copying previous work. This is what I'm worried. Okay, clear? The other is all the same. Just find the proposition of nucleic acids for whatever moment it is in the separa plastic. Start from the original nucleic acids and then moving until the fully plastic there. That's for this case. Maybe for the different size, let's say different size like that, this big there, and then this small there. Maybe the original nucleic acid is there, and then the fully plastic is there. It's not necessarily always here. Are you with me?
Yes.
This type of question, the one that I show you just now here, if this is big, this is small, does not necessarily stop there and start there, stop there. No. You have to decide the first one, how to decide it. You have to decide the final one, how to decide it. Summation of force to the left and the right must be equal to 0. Are you with me?
Yes.
That's how you decide it. You don't know the position first. You don't know the position. You don't know that position. You don't know that position. And then you decide by equation. Okay, clear?
There.
The other thing, when you know the position, can you find back what is the moment separa plastic? Let's say the bottom one is 40 mm become plastic. Or top surface become plastic. Can you find that one? Yes, F1, D1, F2, D2, F3, D3, F4, D4, F5, D5. Are you with me?
Yes.
Same thing again. And then can you relate back with the loading again? What is P again? Yes, same procedure again. Just at the beginning procedure to decide what is the moment, separa plastic or fully plastic or maximum elastic, take a while to decide that one. Must know the nucleic acids, and the nucleic acids also changing when the loading is increasing. Why is changing? Because the load to the left and to the right is not the same, so that must be changing to make it the same. Clear, guys?
Clear.
Okay, thank you very much. We stop today. Okay?
Doctor, if the question asked in percentage,
Can also?
but then the top and the bottom different area already for the plastic.
So the top and bottom is not different, right? So no problem. So why not? Let's say 50% of the surface area is plastic. How you draw that one? 50% of the surface area is plastic. Let's say this is 100, this is 20. This is 20, this is 100. So 50%, let's say you put half there. So this is not 50% yet. This is 1/3. And 1/4, right? 50, 50, so one quarter. 25%, this is 25%. So you go further there, this become plastic. And then you decide that area plus that area must be 50% of that area. Area 3, area 4, area 1 plus area 2 plus area 1 must equal 3/4. Correct me not?
Oh, okay.
And then you can draw that diagram. You don't know the position there. You can draw the diagram there. Oh, this is the diagram there. This is the diagram of 50% of the surface area is plastic. Are you with me? That's why you have to create that a lot of question on your own to understand. Are you with me, guys? Okay, thank you very much. Okay, I give you some homework. Assalamualaikum. All right.